we're going to be looking at exponential functions. An exponential function is in the format of y equals ab to the power of x, in which you're multiplying by a constant number. I would make sure to put this on your frame. You might want to put the next example down just as a refresher if you need an example to decide whether or not it's exponential versus linear. That might be a good idea to put it down as well. Pause the video if you need to be able to write stuff down. Please also write off to the side if you have any questions, so that way when you're in class with me, that way you can have those questions answered and know what's going on. Okay, so just something to note, just pause the video, write down any questions you might have, or pause if you need to catch up, okay? So, example 1, determine whether the table represents a linear or exponential function. So remember, with a linear function, you are adding or subtracting by a constant. With an exponential, you are multiplying by a constant number. So if I'm looking at the first one, I'm adding 1 to the x's, which is totally fine. But as I go from 2 to 4, I am plusing 2, 4 to 6 plus 2, 6 to 8 plus 2. This is linear. So both x and y are going up by a constant. And that's with addition or subtraction. So on the second one, we plus 1, plus 1, plus 1. Now on the y's, I am multiplying by 2. This represents an exponential. So x is going up by a positive constant or a plus constant. Y is multiplied by a constant. Okay, so even though there's a plus on the x's, that's okay. You want that plus to be the same. The multiplication occurs on the y. So you might want to make a note of that. Occurs on the y. Again, it might be beneficial for you to write this example on your frame. I'm not requiring you to, but it might be something you might want to put down just so you have a frame of reference to figure out, okay, how do I decide whether it's linear versus exponential? That one's a good one. Now in example 2, this is just your function notation. So remember, with a function notation, you're taking that x value and you're subbing it into the x spot. So we don't touch that left side. And you're just, again, subbing right into that x spot. And you're just using your calculator and typing it in exactly how you see it. When you type it in exactly how you see it, you get 12. And that's your answer. Now, we're going to be looking at the graphs of these functions. So with a linear function, it's a straight line. With an exponential function, it has a curve. So when b is greater than 1, this is what we call growth. And my curve is going to go up. When b is between 0 and 1, this is what we call decay. And we'll talk about this more in 6.4. I would write this down on your frame with those pictures as well. So notice if we have a b that's a negative number, it's not actually listed here. So just something to note. So on the left one, it's growth. Because b is greater than 1, we go up. Sometimes we can go down, and that's just a reflection or whatnot. On the right, this is decay because our b value is between 0 and 1. Again, we can have reflections depending on that a value. So example 3, we actually have to graph this. So how do you graph a curve? To start off with, it is best, and you can do this with a line too, I would create a table of x and y values. Step 2 will then be plot those values. Step 3, connect points. And it should be a curve. Okay, so what does that actually mean? So when you're picking values, you want to pick a negative, you want to pick 0, and you want to pick a positive. I would go with 5 points so you can truly see that curve. I'd go with -2, -1, 0, 1, and 2. They're easy numbers, right? So our work here is you're just subbing in to that x spot. So notice you're just subbing in. It's kind of like example 2. And now we're just getting that y value after we calculate it. Sorry, just typing in my number here. All right, so we get a decimal, and that's okay. Or you might get a fraction depending on your calculator. I have 2/9. When I sub in 3, or -1, sorry, I get 2/3. If I sub in 0, I get 2. If I sub in 1, I get 6. If I sub in 2, I get 18. So now I have points because I have an x and a y that I can plot. All right, so -2 and 2/9. It's an estimate, right? Because you can't really get an exact on there. -1, 2/3. 0 is at 2. 1 is at 6. And 2 is off my graph. Okay, so if I'm looking at the above, it's going to follow this graph. Okay, so I'm just going to sketch my line then. Notice I wasn't perfect, but it's a rough sketch, right? So state the domain and range. Domain, how far to the left do I go? That'd be -infinity. How far to the right do I go? Remember I hit an arrow here, so that's going to be +infinity. Range, how far down do I go? Notice on this range here, it doesn't actually cross that x-axis, so it only goes to 0. And on the y, how far up do I go? You can see it's an arrow, so it's going to be +infinity. That's your domain and range. Now the last part of this is compare the graph to a parent function. Okay, so we've got some things to discuss on this. What's a parent function? So a parent function is going to be f of x equals 3 to the power of x. So pretty much they're asking, what did that 2 do to the graph? Well, the 2 is going to multiply it, which means that it's going to stretch this, okay? So the 2 stretches the parent. Now, if you're wondering how I know that, you could create a table and do the exact same graph, just without the 2. So if I do it without the 2, here's kind of what it looks like on my graph. So notice, if I zoom in here, notice there's a stretch here to here and here to here. So the graph gets stretched vertically. So that's just something to note. I know that's something we'll need to work on, and we'll talk about this more and more as we're going here, because we haven't dealt with this before, where you have to decide what is happening with the parent. So again, we'll get practice with this. Graph 4, or example 4, exact same thing, set up, just another practice problem here. A little bit more room though without steps. Again, just subbing right in. And calculating. Sorry, I'm just taking care of all of this first. Oops, wrong spot. Give me a little bit of time to write that out. And the first one we get 6. The second one, we'll get 3. Third one here, we'll get 3 over 2. 1, we'll get 3/4. If you want the decimal, that's fine. On this one, we'll get 3 over 8. Okay, so -2, 6. -1, 3. 0, 1.5. 1.75. 2.375. So this graph is a decay because we're going down. Okay, domain. To the left, it goes to -infinity. To the y, or to the right, it goes to +infinity. I'll give you a helpful hint. Your domain will always be -infinity to +infinity, or all real numbers. The range So the range is always going to have to, I shouldn't say always, is going to be, it's going to have a number. It's going to be an up or down shift. But it's going to be based off of that 0. So if I look at this, how far down does my graph go? My graph goes down to 0 and up to positive infinity. Again, there's going to be a shift on that. Then we got to compare to the parent function. So the parent function is without the 3 and without that plus 1. So when I'm looking at the parent, it's just that whatever's in the parenthesis to the power of x. That's how I'm finding that parent. So based on what we have experienced on the last one, the 3 stretches vertically, and that plus 1, what does that do to the graph? So if I were to graph 0.5 to the power of x, I'd be at 0, 1. And I'd also have at negative 2, or at negative 1, it'd be 2. And at negative 2, it'd be 4. Okay, so it's going to look just like that. So again, talking about that stretch vertically with that 3. But what does that plus 1 do? So that plus 1 moves the graph a little bit. It's kind of hard to see on here. But the plus 1 actually shifts the graph to the left 1. So here's what I want you to figure out. So if A is different, it's going to be a multiplier. It stretches it. Okay? If you have anything with the x, plus or minus on the x, this shifts the graph left or right. Now you're going to ask me, how do you know the difference? Positive goes left, negative goes right. I would like you to put that down on your frame. Again, we will discuss more of this, what's happening with the graph, and how that stuff is going to shift. And we'll look at it visually with a graphing where you don't actually have to graph, and we'll discuss it so you guys get a better idea of, without having to graph the parent function, you'll just kind of know right away what is happening with those shifts. Like I said, we'll discuss that when I'm back in class, so that way you guys have a better idea and we can discuss it together. So this is our notes for today. Please complete the Google form, and then when you're done with that, please just work on something else.